do this real quickly. Number which? Number 25. Number 25. Okay, we are continuing with number 25, where they ask about the domain of a what's called a rational function. Rational function just means a polynomial divided by a polynomial. I have rewritten it, changed the name from P to F. I also rewrote this a little bit because you have the question and answer in your review here. So I'm going to change it a little bit and see if we can get through this. When they ask for domain, basically your domain going into these, assuming it's not a story problem, it's going to be all real numbers, unless you have an issue of some kind with math. And one of the things that causes a problem is taking some fraction and putting a 0 on the bottom of the fraction. That's one of the big things for domain issues. We have a fraction, so we have to make sure we do not have a 0 on the bottom. Right? You cannot do a 0 on the bottom. You can't take a square root of a negative. You don't do logarithms in this material, but you can't do a log of a 0 or negative. There are various little things of that nature. In K through 8th grade, about the only ones you have to worry about is a fraction with a 0 on the bottom or a square root of a negative. Those are about the only things you have to worry about that cause math issues. So we don't have any square root signs in this. We do have a fraction. You gotta make sure the bottom's not 0. What you want to do in general terms for any fraction, whether they're asking for a domain or not, when you get a fraction with a bunch of x's and stuff on it, you kind of want to factor the tops and factor the bottoms. And then you reduce your fraction down by canceling like factors. And you've all seen this process before. If you have things 2 times 3 times 3, for example, divided by 3 times 5 times 5 times 7, you can cancel a 3 out of them and say, oh, the 3's go away. If you have something like this, now I can't do anything top to bottom. I need my fractions to be written as 2 or more things that are ready to be multiplied across on the top, ready to be multiplied across on the bottom. And though we have a multiplication here, 5 times 5 times 7, this plus sign right here, that's what I always refer to as the basic form. This bottom of the fraction is an addition because it's something plus something else. I have to have it just a bunch of stuff ready to be multiplied together. If I wrote it like this, if I had that, now I've got just a multiplication on the bottom. I have a big set of parentheses, times 2. I have a 3 times 2. I could cancel my times 2 if I wanted to. If it's just stuff being multiplied, then I can cancel top to bottom of the fraction. This bottom is 3 things being added and subtracted. The top is 3 things being added and subtracted. We need to write these both, top and bottom, as stuff being multiplied together. I'm going to write out the top and do what's called factoring. First thing you do when you factor is you look and see if there's anything in common to every term. Like, for example, if I gave us a 5x squared minus 5x minus 30, I'd look at it first off and say, well, there's a 5 in every term, and I would pull that out. I didn't do that in this one because they didn't do it in theirs. But you always want to check and see if you have something in a factor in every single term, like 5 times something, 5 times something, 5 times something. If you do, pull that 5 out. We don't have that going on for ours. So you check that it's not there. Next thing you say, well, it's a quadratic, and quadratics you're going to factor as the 2 sets of parentheses, assuming there's nothing in common to every term, right? So we're going to do this. This is basically foiling backwards. So I'm going to write that. I put those in blue for a reason. A lot of times people look at things of this nature and they say we're looking for two numbers that multiply to be -6 and add to be -1, and that's correct. It'll work that way in this case, but that adding together to be the middle term does not happen unless it's just a plain ordinary 1x squared. If you get something like this, whatever, I'm just going to put in a -8. Whatever I get when I factor, I have no idea what I'm going to have here. I'm going to get a 5, just so nothing factors out. If this were to factor, I would not get two things that add together to be a -5. That middle term adds up to be that. It only works if it's just a plain ordinary x squared. So I personally don't deal with that. I think the time saving is pretty minuscule considering that you don't know what to do if it's not just a 1x squared. So we're going to say I need two things that multiply together to be an x squared, x times x. These are our firsts, outers, inners, lasts. Right? So I'm going to ignore the this one for right now. First times first has to be x squared. Last times last has to be a -6. Well, if I'm looking for two things to multiply together to be a negative, it means one of them's got to be a positive, one's got to be a negative, and I may not know which is which. But it might be a 1 and a 6, might be a 2 and a 3, 3 and a 2, 6 and a 1. I kind of repeat it up. The 2, 3, 3, 2, they're kind of the same thing. So I'm going to get rid of that. Same with the 1 and 6 and 1, they're gone. So I've got two possibilities, 1 and 6 or 2 and 3. Those are going to go in these positions. If I try the 1 and the 6, it might be a -1 and a +6. It's not going to be. But unless you're good at this, you probably won't know until you actually try. So what you do is you take a guess and you say, well, I'm going to try this, and I'm going to plug them in here, and we're going to see. I know one has to be negative, one has to be positive, because these lasts have to multiply to be a negative, specifically -6. If I do my first times first, x times x, I'm going to get an x squared. That's why I chose them. If I do my outers, and then my inners, and then my lasts, I know out here I'm going to have my last times last, which is -1 times -6. I chose these two to give me that, so I know that this and that are covered. I need to check to make sure the outers and the inners actually work. First times first, x times x gives me x squared. Outer times outer, they're both positive. Those give me a +6x. Inner times inner, -1 times +x gives me a -1x. Last times last gives me the -6. That's why I chose it. These ones here are the ones that I really need to test to make sure that they add up to be that -x. And in this case, they don't because I didn't choose the right ones up front. We have to have it equal that top because I'm trying to factor the top. This does not equal the top. What happens if I turn these around? If I make it a +1 and a -6? First times first is still that, last times last is still -6. All it does is it makes this a negative and that a positive. And if that becomes a negative and that becomes a positive, it just changes the sign of that middle term. So if you don't get the right value, then changing the signs won't really matter to you. If you do get the right value, but it's the wrong sign, you know you just have to change the sign of those into your outers and your inners. So in this case, it doesn't work with the 1 and the 6. And if I turn it around and put the 1 here and the 6 there, we still have the x and the 1 linked together and the x and the 6 linked together. So the 1 and the 6 just won't be it. This is not a real world thing. It is a math teacher thing. When you have numbers that are close together, like 2 and 3, versus far apart, start with the numbers that are close together first because math teachers are more likely to give those to you. Little point, but if we have two numbers, 2 and 3 are close together, your teacher's more likely to give those to you. I've been noticing that for years and years and years. Do not know which is which, so I'm going to go ahead and I'm going to purposely put the positive on the 3 and the negative on the 2. I don't know, maybe it's right, maybe not. X times x, first times first, these are our first terms. Outers, inners, last. First terms are x times x, they give us the x squared. That's why we chose them. Outer times outer of this formation. These are on the outer. Positive 3, positive x gives us a positive 3x. The ones on the inner are these ones. So negative 2, positive x. If I multiply those, I get a negative 2x. If I multiply my last times last, I've got a negative 2 and a positive 3. Those give me a negative 6. I know that gives me this. It's why I chose them. I know my first times first gives me that. That's why I chose them. These are the ones that I really have to check to make sure. Positive 3x, negative 2x gives me a positive x and a negative 6. And then I look up here and I say, is it that? And I'm like, oh, it's close, close. That term right there, if it were a minus x, it'd be perfect. That's the outers and inners combined. I got the wrong sign because I put the wrong signs here. So I'm just going to swap these signs and make it a plus 2 and a negative 3. These my first times first being an x squared. These my last times last being a negative 6. My outers are now a negative 3x and a positive 2x. When I do it that way, it just changes that sign. So if you get the right number but the wrong sign, just change those signs on that. Anyway, this here is the correct factorization for that top. So if we do it, we get x plus 2 multiplied by x minus 3. And then we have to do the bottom at the same time. So I'm going to sort of scooch the bottom over here on this right side. Get rid of this. Because I've already done this, I'm going to go ahead and erase this stuff, leave myself a little bit more room. I'm going to write this over a little bit more to the left, leave myself a little more room. So factor the top, we need to factor the bottom. The bottom is the issue when it comes to the domain. We don't care about the top for the domain. I'm just saying in general terms, factor tops and bottoms. If all you care about is doing the question they ask very quickly, then you're going to want to ignore the stuff I just did over here, except we're going to do the exact same techniques on the bottom. So this was kind of a warm-up for us. We really need to worry about the bottom. And we kind of sort of, if we really want to know what's going on with this fraction, we do need to worry about both top and bottom. And my suspicion is when I turn to the next page or the page after, they're probably going to give you some other questions on these type things. And we're going to want to use the same methods. So just like before, we're going to FOIL backwards, and I need my first times first to be the x squared. Negative 6x will be the outer times outer, and the inner times inner combined. The positive 9 will be the last times last. So we're going to FOIL backwards just like before. For this arrangement, these ones are on the inside, they are the inners. These are on the outside, they are the outers. First term, second term, I want to be here. First times first, these have to be the x squared, x times x. I don't worry about these yet. I think in terms of how can I get to a positive 9? Both of my signs have to be the same. It's either got to be both positives or both negatives. And if I think ahead about this, I know I'm looking to get to a negative, so it just kind of makes sense that I'm going to have both negatives. It's not an equal sign, it's a negative times a negative. But I can multiply a 1 and a 9 together, or a 3 and a 3 together. We're going to choose the numbers that are close together. We're going to choose the 3 and the 3. And if I'm looking to get to a positive 9, maybe it's those. All right, so if I try these, first times first is x squared. I know my first times first is going to work to give me that x squared because it's why I chose them. My outers are these, x times negative 3, which is negative 3x. For this shape, the inners are the ones on the inside, so these ones, negative 3 times positive x is negative 3x. And if you're looking at these, they're going to combine to give us that. Last times last, -3 times -3 is +9. It's why we chose them. So we do get back x squared minus 6x plus 9 with that factorization. So we know it's x minus 3 multiplied by x minus 3. That's the bottom of the fraction. At this stage, we want to think in terms of top and bottom. Do we have any light factors? The top has 2 factors. It has an x plus 2, has an x minus 3. Bottom has 2 factors, x minus 3 and x minus 3. They're both the same factor on the bottom. We don't look at the bottom and say that, oh, there's an x. There's not an x. There's that entire thing inside the set of parentheses, because it's the sets of parentheses that are being multiplied by each other. So when we look top to bottom, to simplify top to bottom, we have to look at the things being multiplied, and that's those 2 sets of parentheses on top and bottom. And if we look at it, they both have an x minus 3. We can cancel those away. One of them on the top takes care of one of them on the bottom. That goes away, this goes away. I'm about to write something that when I finish will be correct, but the first write through won't quite be correct. If I say this, oh, I guess it'll still be correct. Didn't really realize that until right this minute. I gave us the same thing on the bottom. This thing here tells me that I cannot use for my final result, I cannot use a value of 3 for x because it puts a 0 on the bottom of the fraction. Didn't even think ahead to realize I kind of have the same problem here that I would have had right up here, and so failed to illustrate a point that I'd like to illustrate. When I look at this, I know I cannot divide by 0, so I look to see what would make that bottom equal to 0, because I can't use this. I can't use the x minus 3 equals 0, which is x equals 3, which means my domain is x cannot equal 3. So that's the domain. And I'd have to find some way to write it, and that's not the way they write your answer choices. So I'll have to look at the answer choices and find the one that matches. I'm going to rewrite that in what is called interval notation, because I believe that's what they use for them. I'm going to go ahead and erase this stuff here with the factoring. So I'm going to erase that. We cannot use a value of 3 for interval notation, because I would, at this stage, I'd be looking at my answer choices, because I always want to check my answers, and I'd be going, they don't want that kind of an answer. I don't want to start working on this in the form that they have it written in. I can't do anything with interval notation at this stage. I have to wait until I'm down here and then convert this to interval notation. So if I look at their answer choices and say, how can I match all this stuff to interval notation, I really can't do a whole lot with it. This is just pure algebra, get down to here and then say, how do I write it? If it's just you and I talking and I ask you for the domain and you say x can't be 3, I'm going to say, good, great job, it's perfect, x can't be 3. I need to write it like they want it written. And when we go to interval notation, you want to think about number lines. Positive infinity way out that way, negative infinity way out this way. You never really reach it, you just go towards it. You keep traveling to the right forever. I'm going to put a 0, 1, 2, 3. I'll go out to 4 and then sort of give it a dot, dot, dot. All right, so we know that we're not doing a value of 3 for x. We're not allowed to use it. So this number right here, I'm going to put an open circle on that to indicate we can't quite get there. So we can't use it. So if I do the domain, I don't know why I made these dashed lines. I'm not really sure about that. I never do that. I thought it sounded good, but we're allowed to use all those values out there. We just never really get there. All right, so if I look at this, we have just divided our number line up into 2 sections. We have divided it up into the section from here, which we don't quite get to. We can't quite get to that 3, but all that stuff out this way forever, versus the section here, with the 3 that we cannot use and everything back this way, which goes to negative infinity. So we're going to be using the section from negative infinity up to 3. And we can't use the 3. That's the 2 halves. This left half in interval notation, you just write them left to right. This left half, the left side of it is this negative infinity that we never reach. The right side of this piece is 3. When you do not reach a value, you put it with an open parenthesis. So this left side is that. We're going from negative infinity up to 3. It's rounded, which means we never reach it. I could write this in inequality notation if I chose. This way. We're not allowed to use that, but sometimes you have to know this. If we could use that 3, and I did it that way, it would change this to a square bracket. It's not what we're doing, because that tells us we're allowed to use a 3. We cannot use the 3 because it would put a 0 up there on the bottom. So this can't be what we're doing now. But the top and bottom of the square bracket form an equal sign. That's when you actually can equal the number. We can't, and that's why this is round. It means you do not use the value of 3. We're not allowed to use 3. That's the left half. The right half starts here at 3 and goes out that way to positive infinity. So this right side is this. Again, rounded because we're not allowed to use the 3. You never reach the infinities. So this would be 3 is less than x is less than infinity. The fact that you never really reach the end of that number line means you're never going to see one of these with a square bracket on the infinity. That just won't happen. They're not going to give you a square bracket on the infinity. So that means you have arrived at infinity, and it never happens. You don't reach infinity. You always just keep going towards it. So these things are what we'd pull together. I can put them with the word or, but we'd probably pull it together or write them a little more closely. Negative infinity, comma 3. Either the word or a union symbol. I believe they use the union symbols. We're going to look for one of those. That looks like answer choice B. So that is B. I'm going to do one more because I changed the numbers though, didn't I? Yeah, I do not know that they have answer choice B. This answer was a different one. This happens to be the same as their answer choice B. Don't quote me on theirs being B. I didn't do theirs. I made up numbers in a different function. So what did they give you? X minus 3x plus 2, that's 1x minus. Yeah, they didn't do this. If I swap that around. Yeah. I'm going to do one more, and I'm going to kind of go through the algebra and the explanations a little bit fast. I'm going to give us one more, so I'm going to leave that up there for a couple of seconds, then erase it, and give us one more with a g of x equals, and go through the same process. I don't like the fact that I gave you the same thing twice, so when I canceled the x minus 3, it remained on the bottom. I'll probably just flip this one upside down. I'm just going to flip this one upside down so it'll go kind of quickly. But I'm going to do the same thing, but just give us that fraction flopped upside down. So we're going to get rid of this, because you get kind of a thing when you flip it upside down, kind of a thing that sometimes you run into. It's not super tricky. It doesn't add any more algebra. It won't make it a harder question, but just for interpretation, sometimes people don't quite do it right. So I'm going to give us a g of x equals. Give us the same stuff since we've already factored it, but just upside down. So we would repeat the process of saying we're going to factor the tops, factor the bottoms. That top now is going to become x minus 3 times x minus 3. The bottom is going to be x minus 3 times x plus 2. And just like before, x minus 3s are going to cancel. So if I cancel those, I get that. And I'm going to write this now. I'm going to say g of x equals, I wish I hadn't ran into that board chunk there, because I don't have any reason to be rewriting this except to carry the equal sign through and then say, can't quite do that. If I do what I'm writing right now, and I stop and I look at the camera and wait for approval, hopefully no one would approve of this, because that equal sign is not really appropriate. I've done correct algebra, but I left something off right here. If I wrote this in this way, this thing here as my final answer does not tell me that I cannot use a value of 3 for x. Problem is, I wasn't given this, I was given this. And if I use a 3 for x, I'm going to get back 3 squared is 9, minus 18 is negative 9, plus 9 is a 0, that's an issue. 3 squared is 9, minus 3 is 6, minus 6 is 0. I get back that. And that's not defined. So if I go back to where I started, I cannot use a value of 3 for x. This lets me use a 3 for x. If I plugged in a 3 for x on this one, I'd get a 0 on top and a 5 on the bottom. That is not a problem in any way, shape, or form. That is defined. It just equals 0. That's not an issue. I can use a 3 here, but I can't here. Right? So when you cancel the same thing top to bottom like that, you really have to tell the math world, you have to tell anyone that looks at this, you have to tell them, and x cannot equal 3. Here I don't need to state it, it's just kind of implied by the way it's written. If I think about this and I try to use a 3 for x, I'm going to run into that, and then hopefully I would do the like, oh, I can't use a 3. Here I never know that I'm not allowed to use a 3, so I have to tell them. Right, so that's the one little difference between these, and I didn't really think about that in this one. But be careful about that when you cancel top to bottom. If you eliminate the problem, you have to tell them, this is really a problem from the one that you were given, and you have to make sure you state that. Anyway, that's how you would do number 25. I'm actually going to look up the answer for that, and since I never did do the numbers they gave us. So it wasn't the one that I got because I changed my numbers. But anyway, that was number 25, one that was real similar to it anyway, different numbers. So anyway, that was 25.